This question is about refraction. It says a student is investigating refraction of light. And then it asks us, for 1 mark, what is refraction? Well, refraction, as we can see here, which is why it's so important to read a whole question before starting to answer, is when light, or another wave, changes direction at the boundary between 2 different materials or media. Part B says that the diagram shows a ray of light travelling from air to glass. Add labels to show that the angle of incidence I and the angle of refraction R. So this is our incident ray, this is our refracted ray, and we always label the angle of incidence between the ray and the normal. So this is our angle of incidence. And we do exactly the same for the angle of refraction. It's between the refracted ray and the normal. So this is our angle of refraction. Part C says that the student wants to find the refractive index of the glass. And then it says state the equation linking refractive index, angle of incidence, and angle of refraction. Now the refractive index is N is equal to the sine of the angle of incidence divided by the sine of the angle of refraction. The next part of the question shows a photograph showing that the apparatus that the student has available. We've got a glass block, a protractor, and a ray box. The question says, describe how the student should carry out the experiment. You should include what the student should measure, how the measurements should be made, how the student should use a graph to find the refractive index. So there's a bit of a clue here that perhaps if we could make 2 points for each bullet point, then we might get our 6 marks. So the first thing that we would do is position the block so that the ray box can shine the ray through the block, and then we can measure the angle of incidence and the angle of refraction. But the problem is that the block gets in the way of taking the measurements. So the first thing you've got to do, once you've got it in position, is you've got to draw around the block. And then you've got to shine the rays through the block, and you've got to mark around the block a range of incident and emergent rays coming out of the other side of the glass block. So then the next thing I was write is that then mark a range of incident and emergent rays. Then they've got to measure the angle of incidence and measure the angle of refraction. So it's got to look just like this. You know, you might put a little cross there and a little cross there, and then having drawn around the block, remove the block, having seen the other side, and then you can work out where the refracted ray is going to be. Then you're going to have to plot the graph. Now, if you plot a graph of sine I against sine R, then it will look like this. Now the gradient of this, which is always the change in y divided by the change in x. Here, sine I is the y, and sine x is the r. So sine I over sine r is the refractive index. So the final mark is to measure the gradients to determine the refractive index.